Good morning. I am Dr. Usha Rani, Professor RMT Engineering College. I am going to brief about the topic of unit commitment. What is unit commitment here as the combination of generating units are available in the power system. So you have to determine the combination of available generating units and scheduling their respective outputs to meet the forecasted load with the minimum production cost under some operating constraints, or you can say the optimal operation state of power generation units connected to an electric power grid. You have to find out that one for a certain load request. Okay, that is the decisions which combination of generating units you have to pick up. If suppose 10 numbers of generating units 1, 2, 3, 4, 5, 6, 7, here I can have a number of combinations, suppose 135 or 246 or 234, like that. On based on this combinations, which combination gives minimum fuel cost, that you have to select. That is the unit commitment. Here there are three methods. In that I'm going to brief about the topic of priority list method. This priority list method is simplest method. You have to create a priority list of units. A simple shutdown rule or priority list schemes must be obtained. Enumeration of all unit combinations at each load level. How we are going to find out the full load average protection cost, as you have to multiply the net heat rate at full load into fuel cost. You have to find out full load average cost, protection cost for all the given cost equations, and then you have to frame a table. In that, in ascending order, you have to write the full load average protection cost and the combinations. In that, whatever the load demand given, in the number of generating units you have to select. That is the procedure for this. For example, I can consider the question as there are three fuel cost equations given, F1, F2, F3, and they have given the maximum load values. So unit 1, the maximum load is 600 megawatt. They have given the equation 561 plus 7.92 P1 plus 0.001562 P1 square rupees per hour. Similarly, F2 equation, F3 equation given in the question. Each maximum load is given. Obtain the priority list for the unit commitment problem. So the procedure here is we have to find out first step full load average protection cost for unit 1, 2, 3. Okay, and then you have to form a table in ascending order. You have to fill up the values of full load average protection cost. So for finding full load average protection cost for first equation, you have to write fuel cost and net heat rate divided by, you have to substitute P1 value as the P1 maximum. So in that equation, the F1 equation is this one. I have shown this 561 plus 7.92 P1 plus 0.001562 P1 square. In that you have to substitute P1 as P1 max 600 megawatt. I have substituted divided by P1 max. That value 600. So after simplification, the answer is now 9.7922. Similarly, full load average protection cost for unit 2, we have to find out that value as F2 by P2 max. P2 max is 400 megawatt. In the second equation, I have substituted 400. So the answer is 9.4. Similarly, third unit full load average protection cost, F3 by P3 max. P3 max value given in the question is 200 megawatt. I have substituted in the third equation. So after simplification, the answer is 11.188. So we have find the three values. In that, minimum to maximum, that is in ascending order, we have to frame the table. Okay. So here first one minimum value as unit number 2. So that value is 9.4. The maximum megawatt as 400. Next value as unit 1 9.792, 600 megawatt maximum value. And last as third unit 3, the value as full load average protection cost 11.188. The maximum megawatt as 200. Next step, you have to find the unit commitment, the combinations you are going to pick. So here 2 plus 1 plus 3, all the 3 units are you have picked, means the maximum megawatt from the combination. We are adding all the 3 maximum values. So in that 1200 megawatt. Similarly, unit 2 and 1, if you take the maximum combination as 1000 megawatt and unit 2 as 400 megawatt. So what is the inference you can write here as all the 3 units would be held on until load reached 1000 megawatt. All the 3 units are on until the load reached 1000 megawatt, and unit 2 and 1 would be held on until the load reached 400 megawatt. Then unit 1 would be dropped, only unit 2 was running. Suppose this is the priority list method. The example sum I have explained. Suppose in the given question, they have given demand value as 550 megawatt, means they have mentioned the load value. That means you have to select unit 2 and 1 would be operated, because this is a 1000 megawatt as the maximum megawatt from the combination. So the demand is 550. So unit 2 and 1 would be operated. That's the answer for the given PD value. Thank you.